Use substitution on the first one. What do you let u be? du is 7 dx. So 1/7 du is dx. So I'm going to do the integral of e to the 7x. Notice e to the u. Notice I left the limits off. We're going to talk about that. AP is actually really picky about that. Aren't the 0 and the 1 x values? My variable's not x anymore, so I'm not going to write them down for now. If you do AP on open response, will not like it, they will probably dock you there, because those are not equivalent integrals. Does that make sense? So I'm going to do that integral, 1/7 e to the u plus c, which is 1/7 e to the 7x. Now, instead of doing plus c, this was a definite integral. So now, can I do the integral from 0 to 1? Because I have my x's back in. And I get 1/7 e to the 7th minus a 7th. So we're going to learn how to do this today. The reason I did this problem is partially to tell you, you kind of already know how. You could work with it. I'm going to show you a shortcut, but it is one you have to know how to do because AP will test you on the specific shortcut. And that's changing your variables on your endpoints so that you don't have to go back to x's. I'm going to skip this question because it was on your homework and we kind of talked about, oh, do I need to do it? Okay. So the first thing I'm going to do is rewrite it as sine of 2x over cosine of 2x. Everyone agree with that? Because I don't have an antiderivative for tangent. Do I? I don't think there's one on the list. We could make one, but there's not one on the list currently. So I need you to either be sine or cosine. There is only one correct answer, though, because if I chose you to be sine, wouldn't the cosine be in the wrong spot since it's on the bottom? So I need you to be cosine of 2x. Oops, not dx yet. And so du would be negative sine of 2x times 2. So far, so good. 1 over negative 2 sine of 2x du equals dx. Am I going too fast? Are we okay? And so I have the integral sine of 2x over u times negative 1 over 2 sine of 2x du. The sine of 2x's cancel. So I have negative 1/2 the integral of 1 over u du, which is negative 1/2 natural log of the absolute value of u. And u was cosine of 2x. So that puts us at B. Is that B? Whoops, whoa, sorry. So today we are going to learn how to do substitution with limits. A lot of the steps are the same, except step 6. We are going to change the x limits to be u limits. The 1 to 2 was an x value of 1 to the x value of 2. We are going to change that to be u values when we change our variable. On the problems on the actual AP exam, you can either work them this way or you can work them the way we did on the bell ringer. But for your homework today, you have to work it this way. The reason that is because AP will ask a couple of multiple choice questions where they have you do a U substitution, and it's a function you don't know, and they just have you change the variables. And so this is something you have to understand and know. You don't have to use it on every problem. You have that option of choosing to use it sometimes or not, but you do have to know how to do it this way. Let the u be the inside or more complicated function. Find the derivative, solve for dx, substitute u and du in for dx. If you did it correctly, all the x's will disappear or cancel. So steps 1 through 5, completely identical to steps 1 through 5 yesterday. It's the only difference is step 6. We're going to change the limits from x limits to u limits. Then we're going to do the integral. We are not going to substitute x back in. We have successfully completely changed the integral into something completely equivalent with a different variable involved. We're just going to find the number from there. It does save you time. A lot of you won't use this all the time. I would love to convince you. I can't convince you all. But it will save you time. This came up on a BC question the other day, and the people who changed the u's got it right. The people who didn't messed up because it was just more complicated if they didn't change the u's. The thought process was just more complicated. Other than step 6, we are learning nothing new today. Yeah, you can go ahead and turn it in with it. Okay. So number 1, what am I going to let you be? What about du? And so 1/4 du is dx. And then I'm going to rewrite my integral with the new variables. U cubed times 1/4 du. And here's the new thing. The 1 to 2 were x values, right? Well, couldn't I find a u value that's equivalent to those x values? So I know that u equals 4x minus 5. So 4 times 1 minus 5 would give me my bottom u value. Does everyone see how I'm changing the x to a u? If u equals 4x minus 5, then I can find the equivalent u value for the x value. So 1 times 4 is 4 minus 5, it's -1. And then u at 2, right, is 4 times 2 minus 5. You will never show this again, this red part, and that's for your note-taking purposes, but you'll do that in your head, right? 8 minus 5, which is 3. Do the antiderivative. Don't change it back. You don't have to. Because we have successfully changed the limits to be u limits, I don't have to substitute x back in. I'm looking for a number answer. I can find a number answer here. 1/16 times 3 to the 4th, 81. Is that right? 3 to the 4th, 81. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Or 9 times 9 is 81. Yeah. Yes, no, maybe. Minus 1/16. 81/16 minus 1/16 is 80/16. That probably reduces quite a bit. No, 8 goes into both of them, right? 5. So notice what I didn't have to do was put the 4x minus 5 back in. Now, some of you are going, well, why is that the same? What would have happened if I had put the 4x minus 5 in and then plugged in the 1 and the 2? When I plug in the 2, wouldn't 4x minus 5 give me the 3? Or, right? I'm going to get the same numbers either way. Yes. So I plugged in the 3 and I plugged in the negative. And subtracted. So just like I did the other day with definite integrals with endpoints, I'm just plugging in the 3 and subtracting, plugging in the negative. You don't have to change that. I would. It is.
What's the other preference?
To substitute the x's back in and then go back to the limits 1 to 2.
So this is how. So now that we have the numbers, this is what we learned on the first day or whatever.
Yes. No, we still, the addition is the u substitution. Okay. Now, if I go back to the bell ringer, I said, you probably could figure this out without my help. And you did. You did this one without my help, right? Maybe I helped a little, I don't know. This one, we substituted the x back in and then did our limits 0 to 1. What we're learning on this slide is we don't have to do that. And it can make our life a lot easier by not substituting the x back in. Now, one thing I want you to mental note for those of you who will resist the easier way. If you write this integral down with the limits 1 to 2, AP will dock you for that. Why? It's incorrect, right? That's not equivalent. Those two integrals are not equivalent. So be careful about that. Let's try the next one. I will do more examples tomorrow. We still have 5 minutes, but tomorrow is another 2-day on substitution of limits. It is to okay, so steps 1 through 5 completely identical to yesterday. What's step 1? Pick a u. 1 minus r squared, I think that's a great choice. Why is that a great choice? It's more complicated, and I get that extra r to show up. I'm going to change my integral. R times the square root of u times negative 1 over 2r du. I didn't divide over. Is everyone okay? Here's the new thing. This is the only new thing for the day. Instead of from 0 to 1, this will be from 1 to 0. How'd you get 1 to 0? I plugged in 0 into 1 minus r squared, and I plugged in 1 into 1 minus r squared. Now, those limits are backwards. I don't care. I'm going to work it as it sits. It's a variable change. It is what it is. Negative 1/2 u to the 1/2 after you cancel the... Everyone agree with that? Which part? The 1, 0? Okay. So I plugged in, see this 1 and this 0? I know u equals 1 minus r squared. So if I plug 0 into that for r, I get 1 minus 0, which is 1. So I'm going to replace the 0 with 1. Does that make sense? I'm changing it to a u. And then u of 1 would be 1 minus 1 squared, which is 0. So where the 1 was, I'm going to put a 0. So I'm going to change everything to be u's, including the endpoints. On tonight's homework, you do have to do it this way. Make you do it this way at least once. Right, you have to change the endpoints. Anti-differentiate. U to the 3/2 times 2/3. Great news! I don't have to do any substitution back. I can just plug in the 0 and plug in the 1. 0 to any power is 0. 1 to any power is 1. Negative 1/2 times 2/3 gives you negative 1/3. So that's positive 1/3. Again, you would get the same thing if you substituted in. Do what? Right. We'll talk about that tomorrow, yes. Well, we can talk about it really quick. If you want to talk about divergent really quick. Okay. Does anyone remember on the integral, remember, like mean value theorem has conditions. Does anyone remember the conditions to find an integral? We haven't talked about it a whole lot because it hasn't come up yet. Does anyone have notes close? Go read their definition of an integral, of a definite integral. Anyone? Yes. More. F of x must be continuous on the interval, right? We can't integrate on over an asymptote. Think about it. Can you find the area at an asymptote? No. You may try. You may get a number, but it's not right because you know what I mean by that? So this one is a trick question because you can actually find a number. You can. You can do the antiderivative, use a u substitution, you will get a number. However, can you plug 1 into this? Isn't it a vertical asymptotic 1? So this integral does not have a value. It's called divergent. The value is infinite. In this class, that will always just be your answer. In BC calculus, you may have to do an improper integral to find a value. But in this class, you just say not continuous, can't do it, and your word for that is divergent. This is how U substitution can show up on the AP exam, where they make you change the limits. Do you see that? And so this is why I'm making you do that. If you feel like I'm being mean, I am. That's right. That's right. And then you get an easy AP answer. And that is very possible. Chelsea, it's very possible that that's all they test you on.